1 second after the Big Bang. It doesn't sound like much, but in that 1 second, everything changed. Space, time, energy, and matter were born in chaos. To understand what happened 1 second after the universe began, we have to roll the clock back to the very first fractions of a second, to the singularity itself. At time zero, the universe was a singularity, infinitely hot, dense, and small, smaller than an atom. Then, something happened. In an instant, expansion began. This wasn't an explosion in space. This was space itself expanding. It's called the Big Bang, but it's really more of a sudden unfolding of reality. Let's break this timeline down. Planck Epoch, 0 to 10 to the power of 43 seconds. Physics as we know it doesn't apply here. Gravity, electromagnetism, and the nuclear forces were still united in a single, superforce. We don't have a working theory to describe this time, yet. But we know that everything was unimaginably hot. We're talking about 10 to the power of 32 Kelvin. Grand unification epoch, 10 to the power of 43 to 10 to the power of 36 seconds. Gravity separates from the other forces. Matter and antimatter begin to pop in and out of existence as energy condenses, but it's too hot for anything stable. Still, the seeds of structure are forming. Inflationary epoch, 10 to the power of 36 to 10 to the power of 32 seconds. Here's where things go wild. The universe undergoes an exponential expansion. It grows from subatomic to cosmic scales, faster than the speed of light. Space itself stretches, smoothing out temperature differences and distributing energy evenly. Electroweak epoch, 10 to the power of 36 to 10 to the power of 12 seconds. The strong nuclear force separates from the weak and electromagnetic forces. Now, we've got 3 of the 4 fundamental forces we know today. The universe is still a hot soup of quarks, gluons, leptons, and photons, but it's cooling. Quark epoch, 10 to the power of 12 to 10 to the power of 6 seconds. As the universe cools to about 10 to the power of 15 Kelvin, quarks and antiquarks dominate. Some annihilate each other, but for reasons we still don't fully understand, a tiny imbalance favors matter over antimatter. This asymmetry is why we exist at all. Hadron epoch, 10 to the power of 6 to 1 second. Now we're at the point you asked about, 1 second after the Big Bang. During this phase, quarks begin to combine into hadrons, mainly protons and neutrons. Photons interact constantly with charged particles, keeping the universe opaque. Neutrinos, ghost-like particles, decouple and begin to travel freely through the universe. They're still out there today, forming a cosmic neutrino background. At this 1 second mark, the universe is about 1 billion degrees Kelvin. Nuclear fusion is just starting to occur. The lightest elements, hydrogen, helium, and traces of lithium, are beginning to form in what's called Big Bang nucleosynthesis. These will become the fuel for stars billions of years later. Time is moving forward. The universe is expanding and cooling. A few minutes in, full atomic nuclei begin forming. Hundreds of thousands of years later, electrons bind to these nuclei, forming the first neutral atoms. That's when light is finally free to travel, and the cosmic microwave background is born. But it all starts with this moment, 1 second after the Big Bang. To understand that 1 second is to understand the foundation of reality itself. Every atom in your body, every star in the sky, every black hole, galaxy, and thought, all of it was seeded in that first second. The laws of physics, the arrow of time, and the fabric of space all emerged together. It's a reminder that everything, literally everything, came from somewhere. And that somewhere was a hot, tiny, buzzing chaos just trying to become the universe. If that blew your mind even a little, you're officially one of us. Like, subscribe, and share, because CONCURDACOSMO is just getting started.